Hello, everybody. Thanks so much for joining today, and welcome to the fifth episode of our Security Spotlight series. I'm your host, Marie Chidoli, and we have David French as our guest to talk to us about some exciting stuff. We're going to talk about automating security detection workflows, more specifically, benefits of managing detection rules as code, as well as managing threat detection capabilities. So basically, the goal is to improve collaboration, automation, and change management. Before we get into all of the exciting stuff, let's find out a little bit about David first. So David, why don't you go ahead and tell us a little bit about yourself and what you do here at Google?
Yeah, thanks, Marie. Yeah, hi, everyone. David French. I've been at Google for about 8 months now, so not a ton of time. I work on the adoption engineering team within Google Cloud. So our role here is essentially to kind of advocate for blue team practitioners when we think about anything Google SecOps, right? Formerly known as Chronicle. So that involves, meeting practitioners where they're at, developing content to show people how to solve real security problems using Google SecOps. We're a team of practitioners. We're pretty active in the community. We blog, we speak at conferences, run workshops, all that kind of thing, and do stuff like this. So yeah, happy to be here.
Well, thank you for being here. David is on the same team as Dan, who spoke with us last month. And I think they really understate what they do. They're a great team here at Google Security, and they really help us through some tough spots, have an incredible wealth of knowledge. So I'm really happy that you guys are making time to come speak to our security community through the Security Spotlight. How about your background? Do you want to tell us a little bit about your background and how you got into security?
Yeah. So my first job out of school was I was programming intruder alarm systems in banks around the UK. So this is where I got my security mindset, I think, where I learned about all the ways that people would try and, rob bank vaults or ATMs, or how insider threats would try and steal money from the bank and all that kind of stuff, how to monitor and detect attacks, right? A different type of attack from cybersecurity. But one of the things I had to do there was log analysis if something happened on the alarm system. And this was like a long time ago now. We had, you would dial into a modem and the logs would come back line by line, like over a 1200 baud modem. So like, this is a while ago. It's like older technology, but yeah, where I got my security mindset, I guess. And then after that, I worked in a bunch of different IT roles, operational IT roles. And the reason I mention that is because, when you're doing desktop support or system administration or, supporting apps that traders use in the financial services industry, you get an understanding for like how things should work normally. And this helps me spot, right, the suspicious or malicious stuff. So yeah, I think it was around 2013, 2014, I was seeing companies ended up in the headlines for, leaking all their data in storage buckets, or this was when ransomware came on the scene and we started seeing an uptick in that. So yeah, for me, I really kind of gravitated towards the defensive side, writing detections, doing log analysis, just anything blue team to help defend, organizations from attack. So yeah, I did that for a bit. And then, I've worked on both kind of the practitioner side and the vendor side. So I've been working doing threat research, building EDR and SIM systems and building out detection content. And now, back on the vendor side where I can help make, Google SecOps a great product and help practitioners do their job. So yeah, that's how I got in security.
That's pretty cool. And you know what? I was just interviewing someone right before this episode of the Security Spotlight. And one of the things we were chatting about was how having such a diverse background helps in so many ways when it comes to working in security, because you have a much better understanding for what's going on out there in the real world. And when you work in various technical roles, you are able to see into like different nooks and crannies of the like realm of what needs to be protected in a very special way. So I think that that experience really adds up. And well, I mean, hey, look at where you are today. So I mean, I guess that does make sense. But anyway, awesome. Thank you for sharing all of that. I guess let's get into what we are all here to listen to, and that is to hear what you're going to present to us today. So why don't you give us a little bit of an overview, and then we can dive right in.
Yeah, absolutely. So my background as kind of a detection and response engineer, having worked at my last few companies, we've seen kind of this gaining in popularity, this thing called detection as code, right? So I'm going to dive into this in my slides a bit, but essentially detection as code is a methodology for managing your detection content and your security tools using code and automation. So yeah, mature security teams are going to want everything as code, whether it's documentation, infrastructure, configuration of your tools, and now detection rules, right? So that's what I'm going to talk about and demonstrate how to do it with Google SecOps as well.
Perfect. All right. We can go ahead and get started.
Yeah. Let me try and share my screen here.
While David's pulling everything up, I just wanted to let everyone know, please do feel free to ask questions in chat. We will do our very best to get to all of the questions as long as they are relevant to the topic. If we do not get to your question, please bring it over to the community where we will do our very best to make sure, well, hopefully folks will just engage, but we'll make sure we do our best to get to all open questions in the community as well. All right. Thanks so much, David.
No worries. And can you see my slides okay? Okay, good. All right. Yeah, so let's move on to the next slide. We did an intro there about what I'm going to speak about. So yeah, we can get started. So today I've got some slides, but I want to dive into a live demo to try and make things a bit more exciting. So yeah, I'll start off by explaining what detection as code is and how it relates to traditional methods of managing rules in your security tools. And then I'll walk through an example workflow for a security team that's developing and managing their rules as code. We'll talk about some of the benefits of detection as code, why security teams are doing this. And then we'll go over a simple kind of pipeline design for managing rules as code in our SIM, which is going to be Google SecOps in this demo. We'll do a live demo. Hopefully everything works. If not, we'll get to do some kind of live debugging together. And then for a wrap up, we'll talk about, implementation considerations, what type of companies detection as code will be a good fit for, and links to useful resources, right? If you want to learn more about this and learn how to implement it in your organization. So starting off with a definition of what detection as code is. So I like to think of it as this set of principles or methodology that uses code and automation to kind of manage our threat detection content in our security tools. So when we think about a traditional approach to doing this, you've got the security team logging into their tools, manually configuring rules and signatures. And when I say security tools, I'm talking SIM, EDR, firewalls, and so on. So it's important to note this still works fine for many organizations. It's by no means obsolete. And I can talk about what organizations I think can benefit from this a bit later. So yeah, with this approach, we're really borrowing existing software development practices that have been around for a while, like DevOps, using tools to kind of test and deploy our detection rules using continuous integration, continuous deployment tools. And yeah, like I mentioned earlier, this term's been appearing more frequently in the last kind of 4 to 5 years. Mature security teams are going to want to manage, everything as code, especially if you're in a larger organization or a highly regulated industry like financial services. Everything from infrastructure, documentation, you name it, right? So we're talking about detection rules as code here today. And yeah, I've included some links here. We can get the slides out after to everyone if you're interested. These are links to work that's kind of influenced and inspired me as I've been working on this with various security platforms at a few companies over the last few years. All right, so let's move on to talk about what methods and technologies can be used to transform detection content that's stored as code or code artifacts into a functioning rule in Google SecOps in this instance, right on the right. So on the left, we've got a URL rule that's stored in a GitHub repo as a code artifact. And the image on the right shows a URL rule in the user interface of Google SecOps, which we'll see more of soon. So just to acknowledge, everyone's got varying levels of experience with detection engineering, writing code, using some of the software development tools I'm going to talk about. So before I talk about or go into, an example detection engineering workflow that manages rules as code, I just want to provide a brief explanation of some of the core technologies that are used to do this, right? So starting off on the left, we're going to need a version control system software. This is going to track changes to our code base, in this case, our detection rules over time. And a VCS is going to let us do things like rollbacks if we need to, rollback changes, and iterate on our code to improve it and make changes over time. You've probably heard of Git, which is a popular version control system software. And then we're going to need a software development platform like GitHub or GitLab. We're going to use GitHub today. And this is going to provide a centralized workspace, right, for us to manage a repo that contains our code. So when an engineer wants to make a change to a rule, they'll create a pull request and stage their proposed changes and ask their peers to kind of review it and approve it. And then on the right, we're going to use a CI/CD tool. We're going to use GitHub Actions in this demo today. So what this is going to do, when the code base for our detection rules changes in our software development platform, it's going to detect that a change has happened and automate the testing and deployment of our rules to Google SecOps. So here's an example workflow for a security team that's managing their detection rules in Google SecOps using a software development platform like GitHub. So yeah, as with most things, there are many ways of doing this. I've built this a few companies now. This is a way of doing it, not the way. So you can take any parts of this to customize it to kind of fit your needs. So starting on the left, our detection engineer wants to make a change to the detection rules in their SIM. Maybe they want to create a new rule or modify an existing one. So the engineer creates a new branch and a pull request in GitHub that contains their proposed changes. And at this point, no actual changes are pushed out to the SIM. And then the second column here, after that pull request is created, a set of tests are executed by the GitHub CI/CD pipeline job. And these tests are going to check for things like rule configuration issues or problems with the syntax of the rule's logic, and that the rules still match on the intended behaviors and generate alerts. So the goal with running tests at this phase is to catch any issues early on and minimize the risk of any bad changes being pushed out to our SIM. For example, a change that introduces false negatives to a rule, right? And you miss attacker behavior. And the next step is the peer review of the proposed changes happens. So this is where the security team discusses the changes and provides feedback and suggestions on the rule. And then after that pull request is approved, they can merge their changes into the main branch of the GitHub project, which we're going to see soon. And then GitHub Actions is going to detect that changes have been made to the main branch of the project and then push those changes out to Google SecOps' API. So talking about the benefits of detection as code and why security teams are doing this. So one of the challenges with managing detection rules manually in your security tools is that an individual on the team can log in and change a rule without any input or review from anyone else on the security team. So people make mistakes. Someone might make a change to a rule that causes false positives, or worse, causes a failure to detect attacker behavior. And then working in this way, in a software development platform makes it easy for your security team to collaborate on changes, right? Which, in my opinion, leads to more effective rules and reduces the risk of deploying breaking changes. So just continuing on the subject of collaboration, managing your detection content as code makes it easier to share detection rules with the community, right? So during the last 4 years or so, we've seen vendors kind of sharing more of their detection logic with the community. In my opinion, this has helped a lot of companies build stronger defenses against threats. So, you've got the big players, right? Security vendors sharing their logic. And if you're a practitioner working for your company trying to defend it, you can really take that detection logic and use it with whatever security tool you have in most cases. So we've got our own collection of rules that you can find on GitHub here. And the intention of these rules is, to show the capabilities of the YARA-L detection logic and provide people with a collection of rules to help them get started. So with these rules, you're going to want to, test them, tune them, and help them kind of fit your environment before you enable them and let them generate alerts. All right, so next, detection as code gives us more control over the changes that are made to our detection content. I mentioned a bit of this earlier. So when our rules are stored in a platform like GitHub, we can ensure that changes are tested, reviewed, and approved before they're pushed out to our tools. So in this screenshot here, we can see the engineers' proposed changes can't be merged into the main branch of the GitHub project because the tests in the CI/CD pipeline have failed. So yeah, some organizations are going to need this level of change control for the detection rules, as well as their preventive security controls, right? So we're not just creating detection rules for fun. They're security controls that we need to protect. And then, final benefit I've got here, I think. So by borrowing these DevOps style software development practices that have been around for a while, we can build our pipeline to automate that build, test, and deployment phase of our detection content. So obvious benefit of this is, having automation. It can save us time when we're doing testing, configuring rules. If you work for maybe an MSSP, you might be configuring rules in multiple tools, multiple environments for your customers. This is going to help you manage that in a centralized kind of location, right? All right, so last slide before jumping into the demo. So here's a simple design for the pipeline. I'm going to show you how to use it today. So this is going to be a pipeline to manage detection rules in Google SecOps. So starting on the left, we've got our GitHub repo. This is going to be used to store our rules and is where we're going to be working as detection engineers. And then our rule logic is going to be stored in this rules directory. In the other directories above that, you've got some Python modules we're going to use to manage rules via the SIMS API. And we've also got a small command line interface to manage rules, which I'll show you in a minute. And then in the middle, we've got our GitHub Actions workflows. We've got 3 of those. One of them will be responsible for running tests whenever changes are being proposed to our detection content. And then the other 2 are responsible for retrieving rules via Google SecOps. The other one's responsible for updating rules. And then, Google SecOps has got this API that lets us kind of read, create, update, and verify rules programmatically. All right, so that's kind of the introductory theory, what detection is coded, some benefits, why people do it. And now I'll show you how those various components kind of work together and how a security team can manage their content using that kind of code and automation. All right, so just switch my screen here. Let's see. Okay, so this is going to be a hands-on demo for the majority of the remainder of the session. I saw someone mention Dan Lucio's blog post. That's awesome. I love that work that he did. I've got a link to that at the end as well. All right, so what we're looking at here is the documentation for Google SecOps REST API. So this is the newer version of our API, currently in alpha. We'll see that get to GA soon. But this is what my project and example code that I've released is using. So looking at the docs here, we've got this REST API endpoint that lets us manage rules. we can see the JSON representation for a rule object when we pull it from SecOps. And then what I'm most interested in here is the methods that let me manage rules, right? And if you've worked with APIs before, this won't look kind of out of the ordinary, but we've got methods to kind of create a rule, list the rules that are currently in our SecOps instance, update a rule, that kind of thing. So this is what our code is going to use to manage rules programmatically in SecOps. So just to show you another component of the project, this is the detection rules repo that I mentioned earlier, where we've got example rules, right, for the community to look at and deploy in their SecOps instance and explore what YARA can do. Within here, we've got this tools and rule manager directory. And what this is, it's written in Python. It's essentially a command line interface tool that kind of wraps some Python modules up that lets us manage rules via Google SecOps API. So there are instructions here on how to install it and configure it. But the piece I wanted to show you is this is what it looks like, right? The help menu. So you might have seen things like this before where we're just wrapping code up to make it easier to execute. We've got kind of arguments that let you pull the latest rules from SecOps. I'm going to make that a bit bigger. Update rules, verify rules, and that kind of thing. It can also manage reference lists. Again, that's all documented. It's not going to be my focus for this demo today, but if you're interested in that, Dan Dye on my team actually did the last Security Spotlight episode and did a deep dive on that. So yeah, recommend you check that out. So yeah, just to let you know, this is here. And the reason I wanted to show this is what I'm going to use in my GitHub Actions workflows, right? My CI/CD jobs. It's going to make it easy for me to manage rules in SecOps. So that's what we're going to look at next. So before this demo, we're looking at Google SecOps UI now, the rules editor UI, right? So I've only got a few rules in here that I created earlier this week. And if I go back to our GitHub repo, which is here, I've got this Google SecOps demo. It's a private repo. Again, all of this example code is shared either in our community detection rules repo. We've got CI/CD configuration files that work with GitLab or GitHub. So if you use one of those two, you'll have a head start on getting that set up. So yeah, this is the layout of our repo. We've got our workflows in here, which we'll look at in a minute. We've got our Chronicle API modules that are used to manage rules. So create rule, get rule, that kind of thing, built off of the docs that we saw earlier. We have got the rule command line interface that I showed a minute ago that's going to be executed by GitHub Actions. We've got this directory of rules. I've only got a single rule in there at the moment. If you recall back in SecOps a minute ago, I've got 5 rules in there. So we're going to sync our code base with what's in SecOps in a sec. And then, yeah, anything else to point out in here? Yeah, this rule config file, this is an important one to point out. So, and I'll make that a bit bigger as well. So this rule config file is going to control which rules are going to be deployed to SecOps, and if they're going to be, enabled, archived. It stores metadata about each rule, like the unique ID, timestamps for when it was last modified, and that kind of thing. And we're gonna look at how to manage our rules using this file in a sec. And then, yeah, just to jump into this rules directory, if we look at a single rule, this is a YARA rule stored kind of in its raw format, right? So the rules are in the rules directory, and the rule config file is going to control where rules are deployed and if they're enabled or not, that kind of thing. So let's start by looking at our first GitHub Actions workflow. We have one that pulls the latest content from Google SecOps. So I'm just going to run that, and then I can speak to that while that's running. So depending on how you want this to work in your organization, right, you might You might decide that all changes are made in your code base and pushed out to your security tool. And then maybe agree that the security team doesn't use the rules editor to make changes in the UI anymore, or maybe that's okay. And what you want to do is some organizations decide to kind of run a job like this that's syncing the content back from their security tools back to their code base every night, maybe. So it depends on what you want to, how you want to operate, right? So our job is finished running here. Just to call out the most important steps for the purposes of this demo. So every time a change is suggested or one of the other workflows runs, we're running a set of tests, right? And that is going to check the code that's used for managing rules via the API, but also check that rule config file, check that we're dealing with valid URL rules and all that kind of thing. And if any of these fail, an error will be raised, right? And an engineer won't be able to push changes out to our tools. They'll have to fix those tests before they can move on to the next phase of whatever they're trying to do. So yeah, just to call out a couple of these, where we're testing the actual code, we are making sure we can parse all of our rules, making sure we don't have duplicate rule names, that kind of thing. And another one is, you can't have a rule that's enabled and archived at the same time. So we're checking for misconfigurations like that. So our test pass there. And this is where we're pulling the latest version of all rules from Google SecOps. So we've retrieved 5 rules. And the rules are written out to the rules directory. And the configuration for each rule is written out to this rule config.yaml file. And then further on in this job, we'll see the git status command, git run, to see if any changes are pending that need to be committed back to our code base. So we see we've got some new rules that need to be committed, and the rule config file has changed. And then the GitHub Actions job goes ahead and takes care of that as well, right? So commits the changes, and the commit message is, latest content pulled from SecOps API, right? So, and then the job wraps up and finishes. So that was just me running that job kind of on demand. Like I mentioned, you can run that on a schedule if you want to keep your code base in sync with SecOps. So if we go to, we're in the main branch of our project, and if we look at this last commit message that was done by our CI/CD job, we can jump into that. And we can see the changes, right? So all the green stuff is new stuff being committed to the repo. Starting with the rule config file at the top, you can see we've got a new entry for a new rule. Bit of a long rule name there, but that's okay. And this rule is currently enabled for alerting. It's not archived. We've got the unique ID and all that kind of stuff. So you see that for all of the new rules, right, that were pulled back to the code base. And then for each rule, the rule is written to that rules directory with a .url extension, and the content of each rule is just kind of, dumped out to this file. And that's now in our version control system. So if we go back to our main branch, in our rules directory, we can see we have all those new rules. So that's kind of phase 1, like syncing back what you have in SecOps back to your code base. Now we can go through the process of, I'll show you how you can create a new rule, right, using this process. And at this point, Marie, do we have any questions in the chat we want to answer, or I can just carry on going if not?
No questions right now.
Okay.
Thank you. But feel free to ask questions if y'all have any.
Yeah. I can try and keep an eye on the chat as well. So for creating a new rule, I'm just going to use GitHub's web IDE for this.
Dan, I'm sorry, David, sorry to interrupt, but King, you mentioned that your buddy wrote a really great blog. Do you have the URL to post it so everyone can take a look at that later? Figured I'd just mention that real quick.
Yeah, I do have that handy. Let's see. I will put it in the chat.
Thanks, David. Awesome.
Hopefully I did that right. Yeah. Anyway, it's a really good blog series written by guy called Dan Lucier goes through his detection engineering methodology, right? And it's not just it uses a combination of SecOps, open source tools, tools that he's built, research that other people have done that he's building upon. It's just it's a great reference. Highly recommend it. All right, so yeah, creating a new rule. So let's go back to our GitHub project, and what I've done here is open up the web IDE for GitHub, right? If you're ever in a repo, you can just hit the period key and it will open that up, or full stop. Hopefully you understand what I mean by that. All right, so we're on the main branch of our project. Let's say we want to create a new rule. So we're going to create a new branch. We call our new branch new rule. And I'll just call this demo, right? Just for this purposes. And then we're going to switch to our new branch. The reason we're creating a new branch is that our main branch for our GitHub repo is protected, right? So we're going to propose our changes in a new branch, see if our tests pass, go through that peer review and collaboration process, and then commit our changes to our main branch, and then it will get pushed out to SecOps. So, all right, we're on a new branch. I'm going to go to our community repo and just pick a rule at random that I can push to my SecOps instance. So let's pick a GitHub rule. Let's see. GitHub Enterprise deleted. All right, so we need to create a new file for our rule. So I'll just take this rule name here, go back to our working branch. I'll create a new file. So we've got our empty file there, and I'll just copy the contents of this rule into that new file. And just to show you that rule verification part works, we're going to make a mistake in this rule, just to demonstrate that. So all these fields are these are UDM fields. So SecOps normalizes events into our schema. And I can see questions rolling in. I'll get to those later. That's great. Thanks for those. So I'm just going to make a mistake here and make a typo in this field name. Instead of vendor name, we're vendor namey with an extra E. So we're saving that file. And then we need to create a new entry in our rule config file for this new rule. So I can just go down to the bottom of the file here, put the rule name in, and we're going to want this rule to be enabled. So it runs over our logs, and we want it to produce alerts as well if it matches on the intended behavior. And that's it. So we've got our pending changes here in this source control kind of menu. So I'm going to go ahead and commit these changes to my branch. So let's say add new GitHub rule. And we commit those changes to our branch. And let's duplicate this window, go back. Let's go back to our project on GitHub. And yeah, our branch had recent pushes a few seconds ago. So as a detection engineer, you would create a new pull request. You would put a lot more information in here. So you could say, new rule, and then maybe a description of what it detects. This description here is where you would provide pretty verbose information about, the rule's intention, like its design, what is it trying to detect, any assumptions, false positives, what logs does it use, what considerations have you made in terms of like what existing coverage do we have today, how does this rule supplement what you have in terms of coverage, all that kind of thing. And these things that I'm saying now come from really like working with Palantir's alerting and detection strategy. So if you haven't seen that, I highly recommend you check that out. It goes through, designing a detection from start to finish. So yeah, I would add in the description here for my teammates, assign this to myself. I would request at least one reviewer. Again, I'm, this way of working, I'm not authorized to just push out changes, right? That defeats the way of the object of why you're working this way. So once I've done all that, I'll create my new pull request. And then we have It says one review is required, and it looks at like our tests have failed, right? So this is our GitHub Actions workflow that's running. This is where it verifies the RL rules by pinging SecOps' API with the content of the rules. And we can see here that we've got a field name that doesn't exist. So that was that intentional mistake that we made earlier. So what we'll do is we'll go back to our rule and we will fix that in our branch, which is here. So we'll get rid of that extra E. Our new commit message will be fixed typo. And then we'll go back to our branch in GitHub, or our pull request, sorry. And we can see our tests are running again. And then if all goes well, our rules will be verified this time. So you see it's verifying the rules one by one, and it says rule verification succeeded for 6 rules. And we can see a green check mark, right? We like green check marks. Our job's passed. So refresh this page. All right, so the checks have passed. The next phase here would be to get that peer review, right? So I would ask my colleague, hey, can you review this new rule? Yeah, be prepared for, to accept feedback, criticism at this phase, people challenging the basis for the rule, all that kind of thing. And this is where the magic happens, right? So you might have people with, like Marie said earlier, you might have people from different backgrounds, different experience, different skill sets. You might be writing an endpoint rule, and your reviewer might be a security network engineer. So yeah, you're really getting that diversity of thought, right? And hopefully making stronger rules by using those diverse skill sets. So I'm going to bypass this for demo purposes. You shouldn't do this in the real world, but I'm going to do it here. So I'm merging my changes into the main branch. And then if we go back to our GitHub Actions workflow, we can see, our third workflow is kicked off, right? Update remote content. So this has detected that those changes were merged into the main branch. And this job is now running to update content in SecOps. So our tests run again. Reference lists, we're going to skip talking about that today. But yeah, update rules in SecOps based on files in the main branch. So it loads up all of our rules in our GitHub repo from the main branch. It retrieves all of the current rules that are in Chronicle, and it will go through the rules and see what changes need to happen, if any. So we can see we created a new rule for our GitHub rule. We enabled the rule, and we enabled it for alerting as well. And then you get a summary of changes at the end, right? So we've got one new rule created, one enabled for alerting. And yeah, the next thing it does, you might think this is weird, but I can explain this. We retrieve the latest rules from SecOps again and commit them to our main branch. And I'll show you why we do this. So if we go back to our code and we look at our commit history, this is what I committed to the main branch with the new GitHub rule. And this is what our GitHub Actions workflow just committed. So it pulled the latest content from SecOps again. And the reason we do that is, if you recall, when I created the new rule, I knew the name for the rule and whether I wanted it to be enabled or not. But what I didn't know was the unique ID for the rule, those revision timestamps, all this metadata, right? Which is what SecOps decides when a rule is created. So I want to pull all that back to my code base to keep GitHub and SecOps in sync. So that's why we're doing that. Yeah, so I think that's it for creating a new rule. Modifying a rule isn't radically different, right? So you would create a new branch. You could, actually, you know what? We've got time. We can go through that. So opening GitHub's web IDE again. Let's create a new branch. Let's just call this update rules demo. I'm going to switch to that new branch. And yeah, we can update a rule. Let's say we wanted to change the severity from high to medium and priority from high to medium, if I can spell. And then in our rule config file, let's say, do you know what, this one, we want to disable this rule. So change those to false. And then, yeah, similar thing. So update rules, commit and push those changes to our branch. Go back to our GitHub repo and create a pull request. And then you can see our stage changes, right? So we're disabling a rule here. We're updating a rule here. And then let's go ahead and create that. Wait for our test to pass. Oh, and then just to go back to the UI, right? We had 5 rules earlier in our rules editor, and now we should have 6. Yeah, so here's the one that we created as code, and it should be enabled. Yep. And then, yeah, just go back to our repo. So our checks have passed, and then we would merge those changes in, right? And the same process would happen before. Our update remote rules job will run, and then it will, yeah, update rules in SecOps based on our code base. So we can leave that running. Yeah, I think, Marie, we could probably try and tackle some questions at this point.
Sounds good to me. We have a couple. So thank you for your question contributions. It looks like someone was asking for a plugin, and we got the URL for that. So that should be good to go. And then we have a couple of other questions. Have you built out any trainings on DAC that others may access at any time? I'm not familiar with any.
Yeah. You know, this is a second request I've had in the last week or so. So definitely, I think there is an opportunity to create something. What we do have is a blog series on how to build and implement this. And I can share the link. Yeah, I can share the link in the chat. Yes, we have the blog series. We've got example code that works with GitHub or GitLab, which is documented on how to set it up and use it with the SecOps API. So, yeah, we've got some content out there, but not like a training course on Cloud Skills Boost, for example, like we do with other stuff. Yeah.
And for anyone that's looking for I believe it's just the 2-part series right now, David, but I do have in a couple of community forums posts, I linked to your blog series. You guys can also go directly to our blogs page in the community, which we have a lot of really great content there as well. And then I usually post a follow-up, or I will be posting a follow-up in a couple of days with the recording of today's webinar, as well as linking out to David's blog series on detection as code. So keep an eye out there as well. Cool. Okay. Where do you store the credential file used to interact with the Google SecOps API?
Yeah, for this demo, I'm using GitHub's secret manager. I haven't done it with this project, but you could use Google Cloud's secret manager, right, to have your jobs go and retrieve secrets from there, or whatever vault you're using, right? If you're using HashiCorp, but yeah, in this example, I'm just using GitHub's secret manager to store my API creds.
Cool. All right, and then it looks like we have another question from Sam. Does VS Code support IntelliSense similar to how the native rule editor does? Memorizing all UDM files would be quite something.
Yeah, at the moment, that VS Code extension for YARA-L supports syntax highlighting, bracket matching, that kind of thing. But it won't give you like the squiggly lines, right? If you've got a wrong field name or a syntax error, you're going to want to use either the rules editor in the UI for that, which is great, right? Compared to other products I've worked with, to getting that syntax validation and also supporting rule versioning, it's actually pretty good. So yeah, it doesn't support that today. Or you can have your code call that verify rules API method that I mentioned, right? So as you're writing a rule, you could have somewhere else in your pipeline verify the content and raise an error if there's a problem. So short answer is no, not today.
Awesome. Thank you. I really enjoy putting folks on the spot with questions, and David is handling all of them really well. So thank you. Looks like we have one more right now. When using the verify rule endpoint, how are you dealing with API quota/rate limits when working with larger rule bases?
Yes. Today, I think by default, you get 100 requests a minute before you start seeing errors. So you're going to need to incorporate some checking for an error code that's returned and then sleeping so you don't exhaust your rate limit and then your code kind of falls over and raises errors. So yeah, by default, 100 requests a minute, and just incorporate that back off, right? So you don't exhaust that.
Cool. All right. I think those are all the questions we had for right now. Thank you so much for everything that you presented today, David. Again, there is a 2-part blog series in our security community. Make sure you guys get over to the community to check everything out. If you are less active in the community, I highly recommend making sure you at least register and jump in there, once or a few times a week. I am going to be a lot more active in there, posting within the forums just to help circulate content, help get folks' eyes on more information. We also have a couple of events coming up. So on June 26th, we will have our 6th episode of the Security Spotlight series with a special guest. So be sure to register and check out our 6th episode in June. And then I also wanted to give a shout out for the Boston user group. If you are local to Boston, on our security events page, you can check out the registration for the Boston Cloud Security User Group and register to go be part of that as well. Otherwise, I want to say thank you so much, everyone, for all of your time today. David, you are amazing. We really appreciate you going over detection as code. I hope everyone has a great rest of their day. Thanks so much.
Thanks.